Review of optical amplifier. Review of optical amplifier. Optical amplifier. An optical amplifier are used to amplify the optical signal. An optical amplifier is a device that amplifies an optical signal directly, without the need to first convert it to an electrical signal. An optical amplifier can be placed anywhere on optical fiber to provide amplification. See the diagram below showing inline amplifier, preamplifier, booster amplifiers, in the transmission line. Optical amplifiers are bidirectional and optical multiplexing is also possible. It accepts many signals of different wavelength and provides amplification. Types of optical amplifier. EDFA Erbium doped fiber amplifier. RA, Raman amplifier. SOA, semiconductor optical amplifier. Semiconductor optical amplifier. It is small in size. It provides amplification by using stimulated emission, which is similar to laser. In case of laser, amplification of light takes place when light beam causes many reflections between two phases. In case of SOA, the amplification action takes place without many reflections. SOA is indium gallium arsenide phosphorus laser diode which is operating below threshold. By changing composition of indium gallium arsenide phosphorus material, the gain of amplifier can be varied. As the length of SOA increased, the gain will increase. By changing the composition of indium gallium arsenide phosphorus material, maximum gain in SOA is obtained around 1200 nanometer and 1700 nanometer of wavelength. Characteristics of SOA. Here maximum gain is obtained at 1530 nanometer, using indium gallium arsenide phosphorus material in SOA. Raman amplifier. This amplifier works on the principle called stimulated Raman scattering. When an atom is in ground state and it absorbs a photon having a particular energy level. But when the atom falls back from excited state to ground, it emits a photon having different energy. Due to the difference in their energy levels, the vibration of optical cable take place. SRS occurs whenever there is interaction between optical energy and vibrational modes of cable. Architecture of Raman amplifier. Amplification in Raman amplifier. There are two types of Raman amplifier. First, distributed Raman amplifier. Pump signal and input signal wavelength are mixed in optical cable. Here transmission fiber is used as gain medium. Second, lumped Raman amplifier. Interaction between pump signal and input signal is increased by using nonlinear fiber having small core. Parameters of Raman amplifier. Amplification depends on fiber length, fiber attenuation, core diameter. Erbium doped fiber amplifier. It is used to boost intensity of optical signals. It has a fiber, whose core is heavily doped with erbium ions. It works based on the concept of simulated emission. It operates in C-band 1530 to 1560 nanometers, and L-band, 1570 to 1610 nm. Working of EDFA. Laser pump energy at 980 nanometer or 1480 nanometer. Higher energy and weak signal mixed by wavelength selective coupler. Erbium ions absorbs energy by laser pumping, get excited to higher levels. The stimulated absorption and stimulated emission will amplify weak signal. Energy level diagram. Codirectional EDFA. Signal input and pumping is in same direction, therefore referred to as codirectional. Counterdirectional EDFA. Signal input and pumping is in reverse direction, therefore known as counterdirectional. Dual pumping EDFA. In this laser pumping is done from both directions. That is from input and output, therefore, known as dual pumping. Characteristics of EDFA. At weak signal gain is good. Also, noise figure is less. Noise figure is equal to signal to noise ratio input to signal to noise ratio output. Advantages of EDFA. Commercially available in C-band and L-band. High gain. Immunity to crosstalks. Visit our website, www.raulstutorial.com, to visit it.